Pyruvate. Cool. Let's say you are a microorganism that is not capable of cellular respiration. You don't even have a mitochondrion or any of the enzymes for the CAC cycle or any of that stuff. So all you can do is this. Or maybe you're a red blood cell. Red blood cells, this is all they got as well. And it's not the greatest energy production. Per glucose, how much energy have we got again? 2 ATP. So if you're actually capable of cellular respiration, we'll see oxidative phosphorylation a little bit. This is just substrate level phosphorylation, happens in the cytosol. If we're capable of oxidative phosphorylation with the CAC cycle and electron transport, how many ATP do we get again? About 30-ish, give or take. We got 2. So it seems kind of a waste not to have all that stuff, but if you're a red blood cell or certain microorganisms, certain bacteria, you don't have that. This is all you got. But you got a problem. You can only do this so many times. You can only do it so many times. So because there's one giant oxidation step in this pathway, and that oxidation step turns NAD into NADH. And so if you keep doing glycolysis, well, there's only so much NAD plus in the cell. So if you just keep doing this and nothing else, you run out. It's gone. And you don't produce any more energy. You don't do any more glycolysis. It's all over. So the question then becomes, where do I get some more NAD plus? So you just go down to Circle K and you buy some more. So obviously cells aren't doing that. So we got to focus now. So we'll start from a fresh board at where your pyruvate is headed. Okay, we have our pyruvate. So, and unfortunately, so if we're or fortunate, let's say we're an aerobic organism and we're not a red blood cell, then I can ship this off to the citric acid cycle in the mitochondria and have a good old time making a boatload of energy. So, but if I'm not, if I'm a red blood cell or certain bacteria, so one, I'm not going to get lots of energy out of this. So, but I need a couple of big things to happen no matter where this goes. I need my NADH to turn back into NAD+. I don't care what we do with this pyruvate as long as my NAD+ is regenerated. That way I can do glycolysis again another day. Cool, so your muscle cells work out a lot. Lots of anaerobic respiration going on when you work out. Your bloodstream just can't supply enough oxygen fast enough. So that being the case, what's the result of your pyruvate? So it turns into lactate or lactic acid. Okay, so we're going to make some lactate. This is only useful if pyruvate to lactate is what kind of reaction? What's that? Well, both these are going to be under anaerobic conditions. But if this needs to happen, and what kind of half reaction is this? Oxidation. That this is only helpful if this is what? Reduction. And hallelujah, it is. So pyruvate to lactate is indeed a reduction. So it's 3 carbons to 3 carbons. So, but it's a reduction. Great. That's how I get my NAD+ back. So if you're anaerobic, your pyruvate now has to get reduced. Cool. Doesn't use up ATP or anything like that. I just reduce my pyruvate to lactate. That way I get my NAD+ back. This NAD+ can now be used to do glycolysis all over again. Cool. This is what your muscle cells do, and a lot of other cell types for that matter. So certain bacteria take another pathway. What's their pathway? So they'll make ethanol. Oh, really? I see 3 carbons, now I only see 2. Awesome. And you get carbon dioxide. So where do we see this taking place? So yeast, and what is that useful for? Making all sorts of bread, for example, and or making all sorts of different stuff, right? We're in a church, so you know. But the Bible does say wine, which makes men's hearts glad. So there you go. So, but wine, this is what you got going on, or beer, things like that. So alcoholic fermentation. So before you get there, though, so initially, you don't actually make the ethanol. So your acetaldehyde, so your pyruvate splits into acetaldehyde and carbon dioxide. So, and then it's your acetaldehyde that actually undergoes reduction to ethanol. Notice we're going from aldehyde to alcohol, and so technically it's the second step where your NADH is getting oxidized back to NAD+.